Alright, in this video we're going to cover a bunch of miscellaneous machines that don't really fit into any other category of any of the other videos neatly. We're also going to cover the rotary pump and water centrifuge a second time because those were covered quite frantically at the end of the previous video when I realized I had forgotten to include them in the rotary video. So we're going to do them again properly. If you've already seen that me talking about them in the previous video, you can skip ahead, but we're going to start with those. So the rotary pump is quite a simple machine, and let me clear up my inventory. If I put some water beneath it, it's going to suck up the water and put it in, send it out through the pipe. Right? Pretty simple. It does not work if the source is not directly beneath it. No good. But let's do this, and now it will work, because there is a source directly beneath it. And that means that no matter how fast this thing pumps, there's no risk of destroying our infinite water source, because it can only drain this one source but directly below it. A couple things to note. This can, of course, work with liquids other than water. It can work with any liquid. The faster the gear speed, the faster it pumps. And it has a very important constraint, which is it only works if the speed is in the positive direction. So this is positive direction and it's working. This is, now we've got it going in the spinning in the negative direction and it's not doing anything. You can see the screw is spinning, but no pumping is happening. Real pumps and real corkscrews only work in one direction, and Crossroads pumps are no different. It also has a very small power drain, because of course it does. The water centrifuge is quite an important machine. You can see I've got quite a setup around it for demonstration purposes. It's this machine here. Now, I talked about in the steam power section of the heat video that while you could produce distilled water and salt from fresh water with a steam boiler, it was not a very automatable process because there was no way to automatically pull out the salt. And so you could use that to get enough distilled water to jump to for a closed loop steam system, but if you wanted to mass produce salt and distilled water for something else, which I promise you will, you're going to need another machine, and that machine is the water centrifuge. So the water centrifuge takes water in one of the orange sides here. See, this side has an orange ring. And it goes in there, and it pipes out distilled water out one of the red sides. See, this side has a red ring. Okay. It also produces salt, which we can just pull out the bottom of the hopper, as you'd expect. But enough of that. Now, it's a rotary machine, as you can guess by the sheer number of gears around it. But it's a bit of an unusual one in that it actually needs the direction to change. It doesn't care so much about the speed as it does about the direction. So every time we flip the direction, we're going to produce one salt and make one batch of normal water into distilled water. And now this is a quick little thing I made so that every time I flip the lever, the direction the gear is spinning changes. It's just like the one I built for the wind turbine over there in a previous video. This is a simple setup. I use it quite a lot. It's certainly not the only way to do this. It's not necessarily the best way to do it, but I find it quite convenient. I don't want to give you the idea that this is the only good solution. So let's give this a little more power. So every time I flip the lever, we switch direction. Now it only works if the speed is above 0.5. So there is a minimum speed, but other than that, it doesn't care about speed. It just cares about speed above 0.5, then we're good. This is actually one of those rare instances where moment of inertia matters. You'll recall moment of inertia is this I value is basically how heavy a gear is, and I said it usually doesn't matter, but it can make a difference. This is one of them, because every time with this particular setup, like I said, there are better ones, maybe. Every time I flick the lever and switch the direction, this one copper gear that I'm looking at on the bottom, every time it switches direction, its momentum. It's fighting momentum, right? Because it wants to spin. It was spinning clockwise. Now it's suddenly being forced to spin counterclockwise. Its momentum is fighting the system, and we're losing power. So every time I flip the switch, the system slows down. By having a large gear here, we're able to like store a lot. The system is able to have a lot more momentum, a lot more stored energy that isn't switching direction, and we're able to reduce how much we slow down every time. But if I remove this, we're going to see that with each flick of the lever, we're slowing down quite a lot compared to not that much before. It slows down a little bit. The water centrifuge is also interesting in that, unlike most machines that stop if the output is full, it will continue running and just void the extra output. So if you only wanted salt and don't care about distilled water, you can just let the distilled water fill up and just keep producing salt, or vice versa if you only want distilled water. This machine can also be used to reprocess dirty water and distilled water, and dirty water is a byproduct of ore tripling. And this produces a wide variety of different items, not just salt. Now, next on the list of things we're going to cover in this video, we're going to cover the electrical stuff. So Crossroads does not interact with electricity very much. By electricity, I mean forge energy, aka FE, aka RF, aka one of the million other names that it has been called in the history of modded Minecraft. I mean electricity. So Crossroads doesn't use it very much. There's only a couple machines that interact with it, but there are a few, so we're going to talk about them. Very few things in the mod use it. There's a couple of things late game. There are a few things early game, though, which are what I'm about to talk about, that you make it and move it around, but nothing right now that uses it. So it's mainly useful if you've got other mods and you want to produce electricity for them with Crossroads. So the first one is this dynamo, which is a very simple little machine. You hook up a gear or axle to the back, this side without the big orange wheel. So gear or axle, and you spin it. And the faster it spins, the higher the speed, the faster it's going to use rotary power. It drains quite quickly, actually. It drains 100 times the speed squared at every tick if you actually care. Most people don't. But basically what that means is that having one on the rotary system means that it's going to drain pretty much all the power and nothing much else is going to be able to run because it is very power hungry. It is a pretty good exchange rate to forge energy though, and the faster it's draining rotary power, the faster it's making electricity. So it's quite efficient. Now, now the next machine is a Tesla coil, which has two parts. There's the base, this part, the Tesla coil base, it's just called Tesla coil, and the head, which is this part here. Now, the base has a bunch of different sides. There's the blue sides and there's the orange sides. There's one orange side, which is the output, and a bunch of blue sides, which are all inputs. The bottom is also an input. Right? So if we rotate this around so that any of the blue sides is facing the dynamo, which it is, power produced by the dynamo goes in the Tesla coil, which doesn't store very much, but it stores some. Now to transfer this power, which is what the Tesla coil is actually for, we're going to need a linking tool, which is an essentials item and does exactly what it does in essentials, which is if I right-click this Tesla coil top and right-click this one, you see that red line, that means they're linked. So you just saw a couple jolts and then it stopped. Let me explain what happened. Though every time it jolted, it transferred some of the forge energy in this one over to this Tesla coil. But once this Tesla coil filled up, it stopped because it was full. Now the Leyden jar is an item, and it's basically just a battery for forge energy. And we can just put that in the base, just right-click it in, and you see it goes in. And now the capacity of this thing has gone up from 2,000 forge energy to 102,000 forge energy. So we can just keep letting it jolt over. Now, these link exactly the way you'd expect. If I shift right-click here, we clear all the links. There's a maximum linking range of 8 blocks. It says that on the head, so I can link to this. But if I do this one, it says out of range. can also link to multiple outputs at once. They don't all have to be on the same level or anything, and it'll split electricity between them. And if we now pull, and there's a little bit of loss as well. Every time it jolts out like that, every time a Tesla coil transfers power, we lose 2% of the power, because everything in this mod has power loss. There are better Tesla coils later game, which you may be interested, or maybe you don't care if you're not using a lot of stuff that uses electricity. We can also pull out this Leyden jar, which is going to store all of the electricity that was in the Tesla coil in the item, and we can bring it over here, and now all that electricity's come with it. So you can store the electricity in item form. Now the last topic in this video is liquid fat. Liquid fat, hold on. Liquid fat is interacted with through 3 machines, and it is a liquid exactly as you'd expect. It's this liquid. So liquid fat is basically food or hunger points in liquid form, and it's a way to automatically work with food. And it's quite handy, actually. It can be very convenient. So the first machine is the fat collector. This converts food into liquid fat, and it's a heat machine. Now, while most heat machines either want to be kept as hot as possible or as cold as possible, the fat collector wants to be in a temperature range. So if we look at the tooltip, we can see a lot of efficiency numbers, and we'll see that this is happiest when it's in a temperature between 140 degrees and 160, where it's actually 120% more efficient. Now, what does 120% efficiency means? It means we're getting 20% more liquid fat out of the food than the food is actually worth in hunger. So we're actually gaining food, hunger points from our food. But at temperatures outside that range, we're getting various efficiencies which are generally lower as we get farther and farther away. Below 100 degrees, the machine doesn't work at all. Above 200, it will consume the input food, but it won't produce any liquid fat at all, and it just destroys it. So how do we keep it in a temperature range? Well, you'll recall that I showed off a bunch of features involving heat and redstone. So a big one is that these heat reservoirs, we can read the temperature of them using circuits. Like this is a circuit reader. There's the redstone heat cable, which we can connect and disconnect with a redstone signal, and we can just vent heat with a heat sink. So this all works together if we're smart about it and we realize where I'm going with this, which is if I just build a very, very simple circuit, there are certainly better ways to do this. I assure you on that. This is a less than circuit, and then we're just going to. And what temperature did we want again? We want, let's see, I'm going to get my fat collector. Oh, you want 140 degrees. Sure, let's set this to 140 degrees. So this is a very, very simple little system. There's definitely better ways to make this, but you can see I made this very quickly. We'll heat up with my firebox. And the temperature's rising, the temperature's rising. It's going to take a minute because this is a heat reservoir, which has a very, very slow to heat up. And while that's happening, I'm going to explain what's happening. We're going to use circuits to measure the temperature, and if the temperature gets above 140 degrees, we're going to connect the heat sink and just start venting heat to get down below to around 140. Now, in practice, I'd probably want, if I were building this for real, I'd probably want a slightly different number than 140, because 140 is right at the bottom of the ideal temperature range. Not a great thing to aim for, because I've just told it to keep it below the temperature range I want. I might reconfigure these cables. I might use a different heat source than a firebox. Like, this is a case where solar would be pretty good, because solar doesn't only gets to 250 degrees, but we only need 150-ish. So that would be a good case for solar, and so on. But if we just give this a moment to heat up, Let me start building stuff around it because we've got a minute. How are we doing? 116. Come on. Okay, I'm going to add a couple more fireboxes just to make this go faster. One firebox is absolutely enough to run this. It's just because we need it to heat up first. And I'm very, very impatient. Okay, we're getting there. We go. And now we see that it keeps getting to around 140, and then the cable connects and it drops. So every time the cable connects, we vent a little bit of heat. And we're actually, this is working great. We're actually right in the middle of the range over here. So if I put some food in here, let's say potatoes, baked potatoes, sure. If I put that in, it made liquid fat. That immediately went to a tank, so let me disconnect the tank. It made liquid fat. Now the more food value, like the more hunger points and saturation of food is worth, the more liquid fat we get. And of course, we're in the very high efficiency range, so we're getting quite a lot of liquid fat from our food. Every time I do this, it consumes a little heat. So that's a thing to note. Maybe you have a system that can keep it at 150 degrees, but then when you put a stack of food in, it drops the temperature really quickly, and you might get out of your ideal range. So we've got our liquid fat. What do we do with it? Well, there's two different machines we can use it in. We don't need both. We can use either one. We can use the fat feeder or the fat congealer. Let's do the fat feeder first. Now, because everything in this mod is a puzzle, that should not change with the fat feeder. Now, the fat feeder uses no power at all, no power needed at all. It feeds any players in range. Now, I am in creative mode, so it is going to ignore me. But if I were in survival mode, and okay, give me a moment. And I also need to not be in peaceful because that's how this game works. What is the command? Effects, give me hunger 10 seconds. Let's make it a little stronger. Come on. Come on, I need to be hungry for this demonstration. Come on. Really? Come on. This is what I should have been doing while waiting for it to heat up. I should have thought ahead. How am I still on full hunger? Am I doing this wrong? Does that work? Clearly not. Alright, well, if I were hungry, let's not keep waiting on this. If I were hungry... Oh, you know what it is? I just realized I'm an idiot. I've been running around within range of this machine, and yep, I was getting hungry. This machine has been feeding me. That's the thing. The fat feeder will automatically top up the hunger and saturation of any players within range using its liquid fat. I've been running around in a circle trying to drain my hunger while within range of the fat feeder. So I don't know if you recall, but there's around 700 millibuckets in here before, and that is where it has gone. I'm an idiot. Anyway, the range actually varies. So the range depends on how much fat is in here. So when this is half full, exactly half full, is when the range is the largest, 16 blocks. When it's totally full, it's only 4 blocks. When it's basically empty, it's only 4 blocks. So there's an optional extra way to optimize this machine, which is keep it at exactly half full. Now, this is one of those few things where pipes can actually share liquid with them. Most machines, pipes are not allowed to share liquid. It's either input or output only. With tanks, they can share liquid, and with fat feeders, they can share liquid. So now we're balancing the amount of liquid in here, which means if we come up with a system to keep this at exactly half full, we don't need to build another, this is the wrong machine. We don't need to build another one of those systems for every fat feeder. We can just link them up on sharing, and they'll both be kept half full with one system to keep this one half full, okay? Now, there are definitely ways to keep them half full. You can put like a reader circuit or a comparator on a tank and use redstone fluid tubes. It's not actually that hard. This machine can also feed animals. So if I had a pig within range, you can see it's just made them breed, and it's used some of the liquid fat, and it's made a baby pig. Now pigs are made of meat, so if we were to wait for this pig to grow up and kill it, and then run it through the fat collector, we'd probably get enough fat to breed more pigs. Just food for thought. It will stop breeding animals once there are too many of them nearby, just so you don't flood the world with pigs. Really? How did I select? Anyway, this game. The last liquid fat machine is the fat congealer, which turns liquid fat into an item form. So of course we're going to need to hook this up to liquid fat. And let's get some more of that made. So let's just stick some delicious baked potatoes in here. Sure, let's just put in a bunch. So we're full on liquid fat. The output is this side here. It will drop the item on the ground, or if there's an inventory here like a chest, it'll just put the items in the inventory. Now you might be wondering, why isn't the output on the bottom? And that's because there's an input on the bottom. The fat congealer lets you make food out of liquid fat, but it lets you make custom food. So I'm going to say you can turn this off with a redstone signal, and we're going to do that first. So we can make food with custom stats. So it might be that you're one of those people who likes their food to have really low hunger and saturation, so they can like micromanage it and micromanage how fed they are and try and not waste any food ever. Go away, I'm doing it. In which case you can make one food, one hunger, one saturation. Might be you want food that has no hunger but has saturation for some reason. You can do that so that you can like get maximum health regen speed. Could be you just really hate eating in this game, so you can make food with a full bar of hunger and saturation in one item. Whatever you want. So custom stats means, of course, a control scheme. You do that with gears. This is a mechanical machine. This is a gear machine, in fact. That is what I meant to say, without if I wanted to not sound like an idiot. The hunger of the food you make is going to be determined by the speed of the gear on top, and the saturation is determined by the speed of the gear on the bottom. So you can see the formulas in the tooltips there. And this is a horrible way of doing it, but if I just get you spinning, that's a bit faster than I want. That's better. Let's just get that to make some, and we've just made a bunch of edible blobs. Let's turn that off again. You can see this machine is quite fast. Now, they all have a bunch of different stats and therefore aren't static, because this is a terrible way to control it. Do not control this with just a bunch of hand cranks. make an intelligent design here. You've got so many tools available. You have you have the ability to put a reader circuit on a clutch. You have clutches. You have toggle gears. You have large gears. You have small gears. You have ways to waste power. You have ways to make power. You can absolutely make a system that will keep the speed basically constant where you want it. But the way I did it, as the gears slowed down just from, power loss, the speed was changing, and therefore the stats of the items was changing while the machine ran, so they didn't stack. That's a bad thing. You can absolutely control it so you have consistent 8 8s or 17 3s or whatever the heck you want. So you can make food with custom stats. Obviously, food that restores more hunger and more saturation is going to take more liquid fat to make. So it's not more efficient to make super big blobs or to make super little blobs. It's just do whatever you want. It's the same efficiency in the end. And you cannot reprocess these to make liquid fat again. That's the thing. You're not allowed to put them in a fat collector. It will not work. You have to live with your mistakes, I'm afraid. So that's the fat congealer, which is a great way to both process your food late game and mid game, because you can get that extra 20% efficiency if you're in the right temperature range. You get more food from your food. And then you can make it into any stats you want and make every food type in the game into one food type that all stacks, because you did speed control properly. So that's the miscellaneous machines. Next video, we're going to be on beams, which is an exciting big topic and involves magical lasers that do stuff. So that's going to be fun. Goodbye.